This meeting is being recorded.
In problem 9.7 from we're given some information and we're asked to predict or rather give the major product for each of these transformations, and then we're also asked to draw the mechanism. So I have laid out here two different pathways. We have first with A here a geminal dihalide. So on the same carbon, we have our two bromines that will be removed in two elimination reactions. And then over here in green, we see this vicinal dihalide. So we have two different carbons next to each other, which have the halogens here. So those will be removed in two elimination reactions as well. So what we see in this first pathway, we have our geminal dihalide, but the product will actually be the same. We'll see at the end here. So let's take a look and see if we can draw the mechanism. So what we have first is one of these lone pairs will grab one of these hydrogens here. That will cause that bond to move to that to form a double bond here. Those electrons will move down. So we have this grab of that, and then we have this leaving group here with our first bromine. So one proton transfer, one loss of leaving group gives us our first elimination. And now we have one more bromine and one more hydrogen that can be grabbed. So we'll grab one of these. Then we'll see this cascade of electrons. So we have second elimination, and that involves proton transfer and loss of leaving group for that bromine. So now we have this structure here, and we're going to have one more proton that's lost here, and we create this alkanide ion that's shown here. And by using water as an acid, right, we can protonate this alkanide ion here. Oh, so actually we should draw the arrow this way, right? So we're going to grab that proton and we'll form this final product over here. In the second reaction, we'll see that we have our proton transfer happening here. Again, one of these lone pairs on the green nitrogen down here will grab a proton, and then we would have this electrons that form this pi bond, and then we have loss of leaving group over here. And then in our second proton transfer, we could grab different hydrogen here. Well, let's grab this guy over here. That will cause these electrons to move into the bond, and then we'll have loss of leaving group with that second chlorine down there. So again, we have this stage here, which shows a terminal alkyne, but that will be deprotonated once again to form another alkanide ion. And then one last protonation gives us our final product. And you can see these are both the same final product, even though we started with a geminal dihalide with two bromines and a vicinal dihalide with two chlorines.